Okay, now we have a closer look at the flattering algorithm. It takes the pattern S, and the first thing that it does is, if S is a constant sequence, for example 3, 3, 3, 3, it stops and outputs the sequence. If not, it uses Cyclic Shift to arrange the elements of S such that one of maximum height, say let's row A, comes to rest at beat 0, and one not of maximum height, say B, comes to rest at beat 1. If A and B differ only by 1, stop and outputs this new sequence. If not, perform swap of beats 0 and 1, and then you end up with a new sequence and you repeat the process. So you start at 1 with a new sequence. That's what the algorithm does. And when we have a closer look, in, for example, at fixed 3 is our sequence, then it will shift it until the maximum is at beat 0, which is the first beat. So this is already a position where we use the swap operation. So I swap the object on beat 0 and on beat 1. So I swap those two, and I end up with this one. And now we shift it in order to have the maximum at the beginning. So I shift it. And as you see here, it differs, those two numbers differs by 3, so it's more than 1, so then I can do my swap. And here also, it differs by 2, so I do my swap. And I swap 0 and 1, this should be 0. And after that I end up here. And now we got a constant sequence, 4, 4, 4, 4. Now it's 4, 4, 4. And this, you know, is 4. Okay? Since 4 is a valid juggling pattern, is also 1. Because what I do is the following: I got my pattern and I put it into this box. And this box is the flattering algorithm. And my output is 4, 4, 4. And since this thing here is only using operations which don't change the validness of the pattern, then we end up with the new idea that this one is also valid. And we do a right version, because here we can create patterns if we do swaps, and here we go back and see if we can return into a sequence that's already valid. So every performance we do here does not change the validness of the pattern. Right. So you can think of these as a black box. We put something inside and it will perform and continue, and it will end up in a result. And if the result is something we already know, and we know that it's a valid site swap, we we then automatically know that this one is also valid. And on the other hand, if this ends up to be a sequence, for example, like this, if we start with something, I don't know, and we end up here, it's something which is not valid because we don't want collision. And then there's collision right here because the 5 and the 4 will collide together. Okay. And why is it 4? You know, we get the sequence 4, 4, 4, but why 4? So we have to find out what's about this 4. With the 4. So we got here we got our patterns. We started with 6, 3, 3. Then we came to something like this, and we also had this one. And I want to look at the sum. So the sum here is 6 plus 3 plus 3 is 12. Here it's 4 plus 5 plus 3, it's still 12. And here it's 12 again. And the period, it's also 3 all the time. Okay? And our result was 4. And now we want to know what this 4 really is. So we can say here 4 plus 4 plus 4 is equal to 12, which is the same as we do this here, right? Since we know that the period is 3, we could also write it this way. We know that the period is 3 and the sum is 12. So I could also write it as p times 4 is equal to the sum of s, okay? And now I just divide it by the period, and I end up with sum divided by the length, okay? And this is special because this is something you might already have seen. It's called the average. So the average, I will simply write it like this, of S is the sum of S divided by the period, which I often can write as, okay, let's say the sum, start here, go to p minus 1, add up all the digits, and then we have to divide it. So this is the same like this. And this 4 is exactly the average, because on every digit there's a 4, and so the average has to be 4. And this is kind of nice, because when we are here and we see that the sequence is a constant sequence, we automatically know how much objects we need in order to run this pattern. So this 444 is telling me I need 4 objects in order to do that. And this is exactly the same with the average. The average is telling me how many objects do I need to run this pattern. So if you remember our vanilla Siteswap idea, we want to juggle a natural number. We don't want to have half objects. I don't really know how they look. So we can now come up with a solution for that problem. And it's kind of a really nice one. We say that S until p minus 1, so it's period p, the average of S tells us how many objects we need in order to run this pattern all the time. Okay, and since we want a natural number, we got our first rule here, rule 1, express like this, and this one says by using the average, if I calculate the average of the Siteswap, it should be in here. My natural number set including the 0, because I also can juggle 0 objects. And this is something which is really important. This is our first rule in order to get a vanilla Siteswap. It's just part of the whole thing, so this is just the first rule and there's also a second one. And if those two apply to a pattern, then we know that we can juggle it in terms of a vanilla Siteswap.